As we have specified our features and labels, now it's time to train our model, and that's very easy. The first thing we need is to import our classifier or our model type. And for this first example, we are using k-neighbors classifier. Using this line of code, we can import the classifier from sklearn.neighbors. After that, we have to initialize our model. Now, doing this step, it will initialize the model, but it is not trained. To train it, we use the model variable that we created, and dot fit method is the method of model to train. Now it is fitting on something, and within that, as a first argument, we give the features, and our features are stored in the variable features as we have done in the upper program, and our labels are stored in the final labels. I will show you the features and the final labels. These are the final labels, like these are the marks, annual marks scored, and these are the features. We are giving these two variables to our model, and our model is trained. After that, it's time to make predictions. Let's see how our model make predictions. See this. Now, you have to remember the sequence on which you have trained your model. For our case, we have study hours, and then we have marks in previous grade, and then we have the class performance out of 10. And from where I know this, it is from the features. Like you see the arrangement of features. Very first, study hours, then marks in previous grade, then class performance out of 10. So that's the sequence I have to follow while doing the predictions. So okay, now I am giving my model a student who studies 7 hours a day have got 0.83, like it is logically it is 83% marks in his previous grade. And why we have given this in this decimal format? Because this is how our model was created. This is how our model was created. Now if we have changed this while training our model, then we could have used 83. But for this case, as you can see from the features, that our marks in previous grade are in decimal format. So that's why I'm giving my data in decimal format. Otherwise, you can also convert it. And the third argument I am giving is class performance out of 10. So it seems that this student is very hardworking. He studies 7 hours a day, have got 83% as class, and class performance is 8. It is quite a good record. So our model is predicting that this student will gain 82% marks. This is what our model thinks. Now I have run this code in front of you, and it is giving me the same results. Now let's change these credentials, and let me give another student. Let's see how our model will predict on any other student. Let's say I have a student who studied 2 hours a day, have got 60%, and for our model we will give 0.60. That's the 60%. And his class performance is, let's say, 7. It is good, still good, but this percentage isn't good. Study hours normal, and class performance normal. So what we suppose that it is an average student, and our model is predicting that he will gain 78% in his annual exams, which is which is quite unbelievable, because he has scored 60% in his previous exams, but his class performance is quite good. So maybe that's the reason, and let's hope that he will achieve these marks. And this is how the predictions are basically made. You provide the data, to the model and it make the prediction using the dot predict method. In this program, in this part of program, I have made it way more logical for Professor Ahmed so that he will not always open up the program, have placed two square brackets and input the data. I'm trying to make it user friendly. So here I'm taking inputs from Professor Ahmed. I'm asking how many hours your student study and how much he scored and what is his class performance. So that's make more logic. Now Professor Ahmed will know at every step that what he is doing. Now let's say I am Professor Ahmed. I will run this line of code. This is asking me how many hours your student study per day. Let's say I have a student who studied 10 hours per day. How much he scored in his previous grade? Give your answer in percentage. Now, give your answer in percentage. Now, Professor Ahmed will think that, okay, I should give 83. And that's the thing that we have done in this program. He will give us the percentage value and we will convert it into our model behavior. Like our model was thinking that it will give me a 0.83 instead of 83. So that's why we are dividing this value by 100, whatever Professor Ahmed will give us. So I will give 83. This code will automatically convert it into 0.83 due to the third line of code. Okay, what is the class performance of student out of 10? Now he have a good record. Let's say his class performance is 9. Now every time I'm pressing enter, I am giving the data. That data is stored in these variables. Now this 10, it is stored in study hours variable. This 83, this is stored in marks previous, and basically it is stored in MP variable because here we are using this. And this, when I will press enter on my keyboard, it will be stored in the class performance variable. In these variables, there are the integers that are stored, which I will input. And after that, I am using dot predict method of my model and giving it that variables. Study hours, which will be 10. There's MP, which will be 0.83. Class performance, which will be 9. So let's see that I'm hoping that our model will perform good and give it a relatable answer near 80s or 90s. Okay, it is saying that our student will perform 82. Let's hope for more good. He may perform even better. The last topic for this video is predictions at once. Now we have trained our model. It can make predictions. Why not make predictions of whole class at once? For that, we have to provide list within list. And you may have noticed this is what we were doing already. Here in this, there is a list within list. There are double lists in almost all of our data point codes in all of our codes. There are list within list. So here in this example, I have shown you three lists within one list. Now you can say that in this list, it is parent list. Okay. And these lists within the parent list are kid list. And each kid list contain one data point. It is the data point saying that there is a student who studied 2 hours a day, has scored 71%, and his performance in class is 6. Another student, he studied 4 hours a day and got 67%, and his class performance is 8. Other than that, there is 8 hours, 91%, and 8.6 performance in his class out of 10. Now, this is the data of students. I will just store this data in a variable data of students. Now, we can call dot predict method on our data of students, which is list within list. Now see what it is giving me as a output. For the first data point, it is saying, okay, that student will score 64%. This student with this record. And the next student will score 75%. This student with this record. His previous marks wasn't good, but according to his study hours and his class performance, our model thinks that he will perform 75%, which is quite good. And the other person, the other data point is a very like good student. He studied 8 hours a day, got 91% and 8.6 class performance out of 10. For that, our model predicts and our model thinks that he will perform 82% in his annual exams.